Hey guys, how's it going? Back again for some more Python BACnet Stacks Playground. Here we are. We're creating some BACnet applications with Python, which is not an advanced networking course, nor does it get really deep into the weeds of the BACnet spec, which can be very complicated. This course is just meant for HVAC controls technicians or potentially IoT practitioners that want to get a little bit more familiar with Python libraries for BACnet. And then we'll just be working with data types that are Python based, because BACnet has its own data types as defined in the specifications, but we'll just be talking about Python data types that the BAC0 library and BACpipes library handle automatically under the hood. And yeah, please go above and beyond this course. This is just an entry level, maybe an applied computer science course 101 that you would get as if you're a computer science student. You might do something like this, like your freshman semester as an intro to programming. But you should go above and beyond this. I took this on edX, this Georgia Institute professional Python programming tutorial a little while ago. It was really good, especially people like me that aren't computer science students. And then go above and beyond that into Linux, IT, IoT, databases, machine learning, data science, or software engineering. But start off with something kind of basic. So we're still here. We're on part 1 up to day 7. So I've refactored this a little bit where it's just going to be vibe coding checkpoints. So we're just going to be vibe coding these little apps along the way, and then doing theory, a little bit of computer science theory coursework created with AI. So this checkpoint 1 for this week, we just need a BAC0 app that can read, write, and write release some BACnet points. And then next week, our checkpoint will be the BAC0 app will collect data. I might try and do that on a BACnet read multiple. So that's a particular BACnet request that can, from one BACnet device, request multiple points or multiple data points. And then we can just a little bit more code to save that to a CSV file. Later on, we'll get into the BACpipes library directly, pretty much doing the same thing, but in raw BACpipes, which is the underlying library of BAC0. BAC0 is a wrapper library around BACpipes, which makes things a heck of a lot easier than jumping right into BACpipes. And eventually we'll get to BACnet servers and create some kind of little, I'm thinking just like a weather station that exposes BACnet points to the LAN. BACnet objects is weather data scraped from the web that you could bring up on a BACnet discovery tool, which is almost kind of like a cool real-life BACnet application that the sensors and building automation are very cheap, and the outside air temperature sensors can be off by quite a bit. So that can cause problems even in the HVAC systems because the sensors are so, notoriously for being installed in the wrong place, and the sun is shining on them. They read like false values. Eventually we'll get into Wireshark, systemd in Linux, and Docker, just on some bonus operations. But okay, so let's jump into it. We're here. We're doing a little bit of this list operations and methods. We covered a little bit of the basics, some Pythons before this, like Booleans and comparisons, like if than, greater than, some of the math operators, pretty basic stuff. How you can input functions and strings, f strings in Python, and also this length operator. How to append data to a list in Python. So that's like a little array looking thing, data structure. So here we go, day 7. And then we should be up to our point of our BAC0 app. Maybe we'll get into that first. Okay, so here's day 7. This is our AI generated coursework that we'll go through. But then, if you remember, this was our app that we made before. So we have one BACnet device on the test bench on this is my local area network, wired to this computer that I'm teaching this on. And then it has the Raspberry Pi is running a little BACnet server script that's kind of replicating some points that make it look like a real HVAC device. And like what we were doing on these previous lessons is where I have to select my NIC card for my computer. This is a BACnet discovery tool. Check out the previous videos for how to install it. We're going to do a whois right now with the search button. And right now it's collecting data across the network. And these other little devices, these other 3 Raspberry Pi devices, are responding with a BACnet IAM. So this is what the real world BACnet applications would do. They would just respond to a whois, a search here, with a BACnet IAM. So these are the BACnet virtual addresses for these devices that are set up by the technician that set these up in the field. This is the name of the device, and you can drill into the device and see the points. And we are working with the zone temp sensor. So this is just made up data, but in the real world, it would be the zone temperature is 74.5 degrees Fahrenheit. For those of you that want to see the code for these fake devices, they're in here. Just let me know. Reach out to me if you want help running these, but you have to run them on another device. That's what I do. Like, you wouldn't be running it on the same computer as your BACnet scanner, because only one BACnet device can run on the operating system at one time. BACnet is like an inbound protocol, if I'm describing that correctly, and it's not like MQTT or HTTP that is an outbound protocol. So you could have like multiple instances of MQTT and HTTP requesting going on at the same time, but in BACnet you only get one. So for us to run, like I demoed before, you can't run your Python code with BAC0 because the IP address is invalid. Check the software for another network interfaces using port 47808, and that's because I have the scanner open. So if I close that, then I can run our previous BACnet application code. So that's why you can't run natively multiple BACnet devices on one operating system. So you can, I think, if you do some really complicated BACnet broadcast management device, a BBMD, but I never get into that, and people don't do that in the wild. Like contractors, they set up unique BACnet devices in real HVAC system. Each component on the HVAC system is its own BACnet device. And I think it's best to just kind of mimic that, how people set it up in the field. Okay, so here we go. So we did this before. We were kind of playing around with, this is our high alarm. We just made this up. And when we were looking at operators on our previous lessons, we were just saying, like, if the temperature value is greater than or equal to the sensor, these are strings, we can print these type of things. So this is kind of like a cool exercise for our operators that we were looking at, greater than or equals, less than or equals, and we can have a state. So I was thinking that maybe just to clean this up, we would just get rid of this. Keep things simple, because if you remember, let me go back to that. If you remember on our vibe coding checkpoints, we don't have to, like, we were doing kind of some fun things about alarms, and if the value is over the alarm threshold, print, the sensor is high or something, whatever. You can do that. You can make an app like that could even dial out if you wanted to, but We don't have to do that for our checkpoint 1, so we just need to read, write, and write release. So let's try and do that. So right now we are just reading, we're performing 3 BACnet reads, you can see here. So this is an await BACnet read, and we're getting the present value for this point right here, point and address. So remember that this is an F string right here, and typically we only do present value if you want to see the sensor value. And then I thought, there's other attributes that BACnet supports. Most of the time we'll just worry about present value of reading is what the sensor is actually reading, but there would be a point description, there could be units. That's why this printed degrees Fahrenheit. And we were working with these F strings here, and like we practiced before, you can inject data into the F string with curly brackets. So once I remove that, I think I'm going to remove this too. I'm already going to play around with that. So let's just make our code kind of simple. Might have deleted it. Oh no, it didn't delete. So yeah, so it's printing here. It's printing in here. If the sensor is none, print this, and then if the sensor is this, so yeah, so right here it's printing this right here. That's how we can see zone air temperature with a little colon right here. It's coming up through here. This is our sensor, our sensor value, and the units. So that's making 3 BACnet requests to the Raspberry Pi to put all that data together for us. So if we wanted to play around with writing something, we'd even get rid of that just to clean it up a little bit. And this is also like doing, this is our whois. So like when we were doing that on our BACnet discovery tool, the search, that's what this is doing. And then this is actually, this is returning like an object in BACnet. It's not recognizable unless you parse it, but it's we're pulling out the PDU source, and that contains our IP addresses. So that is the other Raspberry Pis on our network. So just like our BACnet scanning tool, probably has very similar code underneath the hood. So if we want to play around with, I think we could try playing around with, we could read the value of our write object, just to say, let's try write, you can call it writing point equals, we're going to have to do another BACnet read, so our target IP address, so the same device we're going to read. We read one point on our Raspberry Pi on this IP address, and then we're going to read another one. So the thing that we can, it can just be our write object and our write instance. So let's try this. Print writing point. Close it out. Stupid VS Code, it always puts this over type on. It's this button I constantly have to turn off, or else it'll start over typing everything. So I'm just going to do not an F string, but just a normal string, and a little comma right here. See what it does. So we should just be reading the value of analog input 1. Okay, so what do we got here? So we have analog, maybe it's analog value. Could just check our BACnet scanner. So if we checked our BACnet scanner again, we want to, this is what I would highly recommend you practice on, especially if you have a real building automation to play with, real BACnet network. So we're on device 12.12, and then we want to, yeah, there's an analog output 1. Analog output 1. So we should be able to read this, which would yield a value of 50. Why didn't that work? We want analog output. Analog output 1, read. I don't know why I aired out again. What is this? Should we be able to just read? I wonder if it's not like remember we were doing comments here. When in doubt, we can use AI. So that works. It doesn't like this for some reason. Device IP, we're just reading. Oh, I know what we do. We're missing our, here, it has to be, we have to give it that BACnet attribute. So we were telling BAC0 to read this, but we weren't telling it present value or the unit or the description. So there we go. So that's our value of 50, the same thing we got from the discovery tool. I think one thing I might do is even just delete this and then just say because we were trying to do, maybe I'll just even make it into a non-f string. Just say sensor because even like typically we only worry about present value, but I just wanted to show you that you can go beyond present value. There's other BACnet attributes that you can read. So that's our sensor, that's our output. And then if we wanted to write to this point, we could say, I think we can do, okay, so maybe we could demonstrate this on the BACnet scan tool first. Kind of lame as I will have to close this and open this every time, but oh well. So here we are. So like what we're gonna do, we're on this point, analog output 1, analog output 1. So we're going to write to the point. Let's write a value of 88. And then let's write to it on priority. BACnet has priorities. Let's write to it on priority 10. I'll show you what that means in a second. Hit the write button. Should be like a little whoop and updated right there. And then in this tool, if you say show priorities, writable BACnet points, and we'll get into this more once we get into backpipes. There's my value of 88 on priority 10. So in BACnet, the building operator, this is defined in the spec of BACnet, is reserved at priority 8. So in the building automation system under the hood, the building operator can override points, HVAC set points, commands, and their writes will come up on priority 8. And then typically 9 through 16 is left for supervisory level control of the building automation system. So the building operator can still override values if they want to. If they need to override the flow set points or whatever command. If it's here, if automation right here, that building operator can still override it here, because anything above the highest priority means the lowest number, which is confusing. But so like my value of 88 at priority 10, if the building operator came in on their thing and did they can override me because they're a higher priority. And let's say the building automation is writing here, I would override the building automation with Python, and then the building operator can override me and priority 8. That's typically how people do things. Never write higher than the building operator, because typically these are left for life safety. Like, it's very rare, I've only seen this once or twice, that like there is a complicated smoke control sequence that the engineers designed, or fire alarm or something, that there's logic can happen above the building operator that they can't release. It will happen up here. So just keep that in mind. That's what priority means in BACnet. There's 16 priorities, and we're playing around with 88. So that's where it's written. So now that previous value was 50. If I read that, run this code again, now it came back as 88, because that's the highest priority that it's getting written to. So if we wanted to release this point, which I'll show you how to do in the BACnet scan tool, and like if you're ever playing around with real live building automation, this is like what you would do if you had this tool available. This is a Windows-based tool, so you'd have to be plugged in locally at the building. But you could do this through Linux and SSH with BAC0. Okay, so right now we're here. Remember our value of 88, that was on priority 10. So if we want to release that, we would say write null. And then we would have to pick our priority, which was 10, and write. See a little message pop up, and then it goes back to 50, because that was just the default value, I guess, running in the device. So there we are. So that's how you release the data. And if we run U again, that would reflect as well. This should go back to 50. Ta-da! Okay, so we wanted to writing point. So if we wanted to, we could say writing point override, whatever. And then we just keep on adding to our F string, so we give it a value. We did 88. I don't think it matters if it's a decimal or floating point or not. We did our 88 at priority 10. And then we could run this again. Other coding languages, I think it could be unhappy that you just reusing the same code as above, redefining variables, but Python is kind of beginner friendly, so it doesn't matter. So, and it didn't take. Why didn't it take? Oh, I think, oh, I know what we need to do here. So like here, so like when we read right here, this will return a value. When we read data, we get value. We have a sensor to read, and then when we want to do a BACnet write, nothing is returned. We just write to the point, and BAC0 doesn't return anything. I think there might be in BACnet, you get like an acknowledgement command or something like that under the hood, but we don't really get into that at all here. Okay, so now we should be, this should go to 88, and then we should be a none type. None type can't be awaited. Maybe we could just say, give it a dummy value. Whoops. Sometimes I think in Python, people do an underscore of just something you don't care. I can't remember, maybe I'm doing something wrong here. I might have to look back on some notes if this errors out. Or else we can just ask AI. Pretty sure, yeah, none type. Maybe we don't need to. I'm pretty sure we need to await this. Let's just try it one more time. I don't think that worked anyways. So why didn't you work? Maybe we just do let's see, analog value. I think we could just run it's interesting that it didn't work. Let's just ask ChatGPT. Why didn't this work on the 88 value? Okay, so your string, your right string is not in the BAC0 format expect. Oh, maybe I'm missing a dash or something. In BAC0, priority is defined with a dash. So I think I might be, this is what BAC0 does, is you need a dash, represent your priority. Let's try that. Come on, big money, big money. And it still didn't work. So I would expect, so it's taking the right, but it's not taking the value. I'm going to ChatGPT. Let's just copy this. See what it does. I don't know if this will work either. Alright, so whatever ChatGPT wrote, we'll get into reading a priority array in BAC pipes, but it's they did something. So awaited right, correct priority syntax. So I must have been doing something wrong right here. So, and then after, we can check that it took value. If you didn't want the priority, I'm just going to say, what was wrong with my code again? Two simple issues. So address object instance property value dash priority. We'll just have to remember that. Maybe I'll put this in the as a note in here. Remember before in our lessons it was about strings. We can put notes in there, and then this is, I'm going to say BACnet write notes, and then or read, BACnet read, BACnet read would just be that. And then that's what we package into an F string right here. Address, object, instance, like the point address, and then whatever prop value you want, and then dash 10 for priority. Okay, so then if we want to write release, I'm just going to say here, so we can do an await, and then instead of a value, we should say null. So now we have to write it, write null to release it, and then we can check it again with a after release. We could do, try this. Then this should fulfill our for this week our vibe coding checkpoint. We need to do a BACnet read, write, a write release null, and I think we covered that here. So okay, so I'm just gonna run this one more time. I think like the point still had some that write override on it, and then we wrote over that priority 10 again and then released it. So like if we run this again, there we go. So we did a sensor read, and then we read the value, which was the default. We'll just mimic the same thing that we did on our BACnet scanner tool, the same operations we just did in Python, just so it really sinks in. So here we do a whois, which is the same as our search right here. We do a read of the sensor value, which is this guy right here. And then if we drill into U and then go to analog input 1, yay, that's pretty much what we're getting right here. So that's our analog input 1. And then if we read the value of our analog output, our command, it's 50. There's a 50. So then what we'll do is write a value of 88, just like our scanning tool, go down the priority 10, which is doing this right here. This is the same thing. We're writing present value of 88 to priority 10, write. And then this tool built in is reading it again, which is actually this, confirming that. Or we could even do this to refresh it, which a little pop-up thing happens there. And then you can even read the priority array, which we'll do in BACpipes a little bit later on. We can see there's our priority 10, and then we do our null, write to U. And that goes back to 50, which we saw right here. So like we wrote null, and then we confirmed that. It's the same thing the tool does with 2 more requests. So there we are. Oh, it looks like this is like an underscore write, which is kind of interesting. I wonder if this works without that. I might close U. I'm gonna try this. Come on, big money, big money. Ooh, it doesn't like that. Maybe I will have to ask why we have to have a right with an underscore ahead of it, but I think that we have this. I might even put this in our notes right here. On a BACnet underscore right, and then this is a BACnet dot read. All right, so here we go. This is our BACnet vibe code app 1. Done deal. And there, to do all this, we had to do a global whois discovery, a read 1, 2, 3, 4 read requests, and then 2 write requests. And one of them contained the null, and the other the value of 88. I think I might stop here. I might do the vibe coding app independently of the days that we study some of the theory. So like when we study our lesson theory, computer science theory, I might just do this on separate days. And if it goes longer than 40 days to complete this, so be it. It's might just be too hard to squeeze into a 20-minute daily lesson. But it is what it is. I think it's important to study coding in Python. Very important. I like to get not only the computer science theory, a little bit of that, but just like you get practice at it. And then it just makes debugging your actual Python applications much easier. So I think that's all for today, guys. I'll push this updates to GitHub and practice, play around with it. Get your Windows BACnet scan tool, or if you use Yabe, any BACnet scanning tool, or if you use the building automation system itself, it's fun to play around with. So feel free to reach out to me if you have any questions, concerns, or comments, or ideas. Thanks, and have a great day.